that when we did calculus, we said there were two sort of main branches. One is differentiation and finding the derivative. And that's where you had your dy dx, your f dash x, and that's all to do with rates ultimately. And that's why you could use it for rates of change. And that's why, we could use it for graphing. And because rates of change, increasing, decreasing, your stationary points, inflection points, and so on, because your stationary points involved your first and second derivative, which included max min, we could extend them to sort of minimum or maximum optimization questions, without worrying about, we can apply them to derivatives and not care about the sort of graph itself, but just optimizing the function. And we said before, and this is where we're going to be focusing more of our attention today, that there is this other branch called integration. Do you guys remember that? Sounds like not really.
Yeah.
In which case, never mind. We're going to be looking at this other branch today. And while this is not technically correct, for now, I want you to think of integration as the opposite of differentiation. And for our purposes, it will be close enough to the truth for now. Does that make sense?
I mean, sure.
So, think about this, right? If I have 3 plus 5, what do I get?
8.
Right. And if I start from 8 and I want to go back to 3, what do I do?
Minus 5.
Right. So to get back to what I had, I need to go 8 minus 5 to give you 3. And so what was the opposite of, I suppose, addition is subtraction, right?
Mm-hmm.
And if I had, 4 times 7, I get 28. If I start from 28, how do I get 4?
Okay. Divide by 7.
I divide by 7. So essentially, multiplication and division are opposites of each other, right?
Right.
And, things that you might not be as familiar with, and this is starting to sort of, accepting the top, there are some exceptions, like, I can't multiply by 0 being an exception, for example, but ignoring those little details, all right? Ignoring those little details, if I take the sine of an angle 30 degrees, I'm going to get a half, right?
Right.
And so I can kind of take the opposite of that and sine inverse a half and get 30 degrees. If I take, the exponential of, 2, I will get e squared, right?
Mm-hmm.
How do I get, 2 back? How do I get 2 back from e squared? What do I do to e squared?
ln?
Yeah, you log it. Now, differentiation and integration, the idea is the same. Technically in math, they're a little bit different. They're not functions, they're operators. But the idea is the same, all right? So you know how you've got functions and you've got inverse functions, right? So these are sort of functions. You do something to it, and then you get another number. You do something to this number, and you get back the original, basically.
But how would you do that with differentiation?
Right. Well, you use integration. So what I'm basically telling you is if we differentiate x to the power of n, we get n x to the n minus 1, right?
Mm-hmm.
So we're basically saying we're going to do the opposite of that. So in other words, some fancy language, all right, don't worry about what this means just yet, but that basically means, integrate. And again, ignoring some details, I'm saying I'm going to get x to the n, plus some detail, but ignore that for now. That's the general idea. We're going to sort of go backwards. Does that make sense?
Yeah.
All right. And let's also think about what that means. Because differentiation is what we do to functions, right? And some of this is probably going to be familiar. So, but we'll run through it briefly. If you start with a function, we call this what? we call it fx.
Oh.
And if we derive it, what do we get?
Another function.
We get another function, which we call
F dash x.
and in words,
First derivative.
correct. And if we derive it again,
Second derivative.
you'll get another function, which we'll call the second derivative, which, you know, we write like this, and this can continue on. Now, that's deriving, right?
Right.
So I already told you that integrating is sort of the reverse, it's going backwards, right?
Mm-hmm.
So conceptually, that means if I integrate the second derivative, I'm going to get,
The first derivative.
right. So conceptually, ignoring a few details here and there, I'm saying that if I integrate the second derivative, I'm going to get the first derivative. And if I integrate the first derivative,
You'll get the function.
exactly. So what might become more interesting is, what if I integrate the function?
Whoa. First differentiate integration.
Yeah, you're on the right track. But basically, we get another function, right? But think about what this function represents, right? Like you might not know the name for it, and I imagine you don't. But whatever this function is called, what can you tell me about this function? What relationship can you tell me? So we're missing a function up here, and we don't know what it's called yet. But what do you know about this function? If I do something, I get something.
If you derive it, you get a function.
Which function in particular?
Fx.
Exactly. So this is the function that if I derive it, I'm going to get this function. Make sense?
Yeah.
So this function is called the primitive function.
Oh.
You know, of fx.
Is
It
there
is
a
also,
function above that?
oh yeah, you could keep going. But, you know, this is kind of just, it really depends on, you know, which one you set, right? They're like kind of people. If you've got a particular person, you know, like a woman, she could have a daughter, who could have a granddaughter, who could keep having granddaughters, you know, the further down you go, right? But that particular woman would also have, you know, a mother and a grandmother and so on.
Okay.
So it really just depends on who you pick as the person that you're, you know, considering everything in relation to. Does that make sense?
Mm.
Because, you know, her daughter still, you know, would just, you know, would have a mother and grandmother and so on. Make sense?
Yeah, makes sense.
So these are kind of like generations of people, if you like. But every single thing here is still, you know, a person, or in the analogy, or here, it's a function. And, you know, you could keep deriving, you could keep integrating, but it's really the relationship to the one you're studying that's more important to you. So, you know, you could make a whole list of people, but I guess it's more important to that particular person, who's their mother, who's their grandmother, who's their daughter, who's their granddaughter. Does that make sense?
Makes sense. Makes sense. Okay.
And with the primitive function, it is also known as the integral or the integrand. So there's a few sort of names for that. But basically, derivative means you kind of start with a function and you get another function, which we call, you know, the first derivative. And you could keep going, you'll get the second derivative and so on. They have their applications that we've covered in previous lessons. Graphing, max min, rates of change, and so on. That's not our focus today. But we also then understand that those are just other functions. Instead of going this way, which is deriving, we could in fact actually go the other way. so that if we want to start from the second derivative and go to the first derivative, we could do what's called integrate, which is integration, and we'll get the first derivative. If we do the same thing with the first derivative, we will get the function. And if we, integrate the function, conceptually, you can understand that if we start with a function, we'll still get another function. This function is no longer the derivative or any of them, but it will be another function where if we were to derive it, it would give us this function. In words, we would call this function a primitive function of fx. It will also be called the integral or integrand of fx. And in symbols, it is given the symbol capital F of x. So lowercase and uppercase mean different things. If you have a function lowercase fx, then capital Fx means the function that if you were to derive it, you'd get lowercase fx. So, is everyone happy with those sort of terminologies right now?
Yeah.
All right. So we're going to not talk about first principles just yet. That's going to sort of come in the application stage. Just get used to this sort of notation, all right? So the derivative of x to the power of n equals nx to the n minus 1. And you know that. Now, the notation is this. We'll explain it more in later lessons, but you get this symbol like this. You put something here, and you put a dx. So let me just write this in sort of green. This basically means I am integrating f of x with respect to x. And basically this is saying what, when derived, will give me f of x as an answer. That's basically the question it's asking. Now, leaving aside a few details, the definition of that, of course, will be capital F of x. There's a little bit of detail I'm leaving off here for the moment, but focus on the notation here. You'll get this squiggly line, which kind of looks like an elongated S. You'll put something after it, and you'll put a dx here. That's basically the question saying, if I integrate, if I derive, what is a function? What is this function? Which, if I derive, gives me this thing in brackets here. And it's read as the integral of fx dx. Make sense?
Yep.
Okay, so let's kind of do a few things. Let's think about some examples. What's the derivative of x squared?
2x.
Right. So what do you think the integral of 2x dx would be?
X squared.
Right? You'd think so, right? Like, if the derivative of x squared is 2x, then what I'm asking, what function, when I derive it, gives me 2x? Well, the answer is x squared, right?
Mm-hmm.
Yeah, exactly. So firstly, when I said earlier in the lesson that the derivative and integration are opposites of each other, this is exactly what I mean, right? If you derive x squared and you get 2x, well, that means going the other way. If you integrate 2x, you're going to get x squared, all right? Let's kind of, I'm going to focus on x squareds and x to the power of n mostly today, but just to give you some brief ideas so you can extend it later. What's the derivative of e to the x?
E to the
Right. So what do you think the integral of e to the x dx would be?
E to the x.
What was the derivative of log x?
1 over x.
So what do you think the integral of 1 over x dx would be?
Log x.
What did we say the derivative of sine x was?
Cos x.
So what do you think the integral of cos x dx would be?
Sine x. Okay. Yep, we get.
Right. So that is the general idea behind it. Now, let's not worry about these other ones for the moment. Let's focus on x to the power of n today. But let me ask you like a sort of deeper question, all right? Tell me again, what's the derivative of 2x squared?
2x.
And tell me again, what's the integral of 2x dx?
X squared.
Right. So remember what this is asking. This is asking what function called fx, capital Fx, when derived, will give me, you know, x squared, or 2x, I mean, which, you know, we call out, you know, lowercase fx. And you guys are telling me the answer is x squared, right?
Right.
Is that always the answer?
No.
Who said no?
I.
Wait, was that Tiffany? So if you said no, when it's, you know, what other answer do you have?
Well, it feels like a no.
Okay, so you don't know, but you just want to say no. Okay, Paris, what do you think?
Oh, I think so.
You think that it's the only answer? Is that what you're saying?
Sure, yeah.
Oh, okay, so that's what you're saying. And Tiffany, what do you think?
I don't think it's the only answer.
Can you come up with another answer then?
No, but like when, like there are multiple ways of making like 8 the same. So that's my reasoning.
There's multiple ways of doing what?
Making 8 with 2. No. Yeah. No. No, there isn't.
If you're talking about prime factors, no, you need 3 2's to make an 8, and that's the only way. But yeah, I'm not really sure what you're getting at. But let me ask you this, right? What's the derivative of, say, 5?
No derivative.
No, there is a derivative.
Yeah.
The derivative of 5 is
0.
0, right? What's the derivative of 7?
0.
The derivative of pi.
0.
Derivative of negative root 2.
0.
So the derivative of any constant is,
Oh, 0.
you guys know that, right? Yeah?
Yeah.
So let me ask you, what's the derivative of x squared plus 1?
X.
It's not x,
2x.
2x.
Sorry.
What's the derivative of x squared plus 5?
2x. Okay.
What's the derivative of x squared minus, 3.5?
2x.
What's the derivative of x squared plus 3 root 2 over pi?
2x. Okay, what are we getting at?
Well, have you not realized?
The dx.
So these, when you derive them, have an answer of?
Oh, right. Yeah.
So it's interesting you're asking me what we're getting at, because that's exactly what I want to ask you, right? So what are we getting at?
The derivative gets rid of stuff that doesn't have the x. So
And therefore,
dx.
the derivative of all of these are 2x, right?
Oh.
So if we're asking what function, when derived, gives me 2x as an answer,
All of those.
are all of these valid answers?
Right. Yeah.
Do we have any other valid answers?
All infinity, all of them. As
So
long- yeah.
what don't we know, if you like?
The dx.
Not the dx, but
Oh.
we don't know the constant.
Yeah, right, right.
Because whenever you derive, if there was a constant term, it will disappear.
Mm-hmm.
Whatever that constant is, it will disappear. So if you're just given the derivative and said, hey, what function did you start with? So that when you derived it, you got, the derivative. We can work out, what type of function it was, but without more information, we won't know if there was a constant or not. So therefore, what you need to understand is that anytime you do integration, you need to do a plus c.
Oh.
This is an unknown constant. So we don't know if there was a constant that was not equal to 0, or if it wasn't equal to 0, what it was. If all I tell you is I'm getting 2x as an answer of a derivative, and then I'm asking you, hey, what was the function? You can tell me that it was some sort of x squared, but you have no idea whatsoever, without more information, what this c was.
Can we
All
do?
right? Does that make sense?
Yeah.
All right, good. So that means then when if you were asking you for the integral of 2x dx, your answer is not x squared, but it's x squared plus c. And you need to make sure you always do this plus c. This is called a constant of integration. And unless you have more information, which you will later on, you can't work out what this plus c is. For the purposes of what we're doing right now, just do the plus c and get into that habit of always doing a plus c. Make sense?
Yeah, makes sense.
So what's the derivative of x cubed?
3x.
Square plus c.
Oh.
So what's the derivative of x cubed?
Goes into plus c.
Well, that's a good question, right?
Derivative, not the integral, right?
Yeah, it's a derivative. So what's the derivative of x cubed?
Oh, yeah.
It's just 3x squared. There's no plus c, all right? What's the integral of 3x squared?
X cubed plus c.
Oh yeah.
All right? What's the derivative of x power 4?
4x to the power 3.
What's the integral of 4x cubed?
X cubed to the plus x.
Wait, what did you say?
X cubed to x cubed plus x.
X cubed plus x.
It's
Sorry.
power 4.
Power 4 plus x.
Not plus x, but
Plus c. Oh, I don't know why I said plus x.
so it's clear, right? Derivative of x power 4 is 4x cubed, which means when you reverse it, it's simply what you had, which is x power 4, and just remember a plus c, all right? Let's do one more since you guys are still having a little bit of trouble with it.
Oh, I got it.
What is this?
Oh, I said x.
What is this?
5x to the power 4.
Integral of 5x power 4.
X to the power 5 plus c.
Good, all right, so now let's do it in general. So we know that the derivative of x at n is?
Nx to the power n minus 1.
Right. So let us now treat it like a sort of, let's kind of go backwards. Let's try and work out a formula in general. So I can integrate both sides because it's an equation. It's kind of like, me, multiplying both sides by 2, adding 1 to both sides, that kind of thing, all right? So I started with a true statement. And what I'm doing now is I'm integrating the left-hand side with respect to x, and I'm integrating the right-hand side with respect to x. It was true before. I do the same thing to both sides. It should still be true after. Okay. Now, so if I integrate the derivative, what happens?
Cancel each other out.
Exactly. So you just get x to n here, all right? Now, what sort of thing is n? Right, you had x to the power of n, so what sort of thing is n?
A constant.
Yeah, it's a constant, which means you don't need to integrate it, right? Just like derivatives, so all your rules from derivatives carry over, right? So if you're deriving like a constant times x, a function of x, you can just take out the constant. And, all those basic rules like plus or minus, they all just, cancel over. So you had, stuff like the derivative of f of x plus or minus g of x. You could just separate out the derivative, right? And so, they all carry over. So just like, addition rules and subtraction rules carry over to each other kind of thing. Derivative and integration rules, are essentially equivalent here. So we can just take out the n, and we don't need to worry about the integration of the n. Make sense? And that means I can derive the n across, and that means I'm going to get the integral of x to the n minus 1 dx equals x to the n over n. And this is just a number, right? So I don't really want to, since I want to make this the subject, I want to make it look a little bit nicer. Let's just increase all the numbers by 1. So, I could use a different letter if you like. Sub, k equals, n equals k plus 1 or something. So what that really means is I'm going to get x to some power k, because, k plus 1 minus 1 is k, dx. These numbers also go up by 1 each, which means I'm going to get x to the k plus 1 over k plus 1 plus c. So this is basically the rule. I mean, you might not have to memorize how we got it. You could kind of just memorize the rule if you like. But what I really wanted to show you was, how we got the rule. But basically, this is read as the integral of x to the k dx is equal to x to the k plus 1 over k plus 1 plus c. And all that's really saying is, what function do I have to derive to get x to the k? Well, it would be this, right? So let us imagine, I'm going to write it on the next page. Let's imagine this time I no longer start with giving you the derivative question. I just start by asking you, what's the integral of 2x dx? I'm going to start with that because you guys know what the answer to that is. You know what to expect. But the rule is the integral of x to n dx is equal to x to the n plus 1 over n plus 1 plus c. So that's the rule. Now let's use that rule to answer this question. Firstly, 2. What do we do with 2? Does the 2 matter? Do we integrate the 2?
No.
No, it's a constant. So let's just think of it as the integral of x, but the 2 goes outside. You don't have to write this out necessarily, but I'm just trying to make it easier for you. Now, if I were integrating x, what power of x is that? hopefully you all know it's x to the power of 1, which means n here is 1. So if n here is 1, let's use our rule up there to do this. So this will be 2 times, we're going to go with our answer here. So our answer is x to the n plus 1, so x to the 1 plus 1 over 1 plus 1 plus c. 1 plus 1 is 2, right? So it's 2 times x squared over 2 plus c. What happens with this 2 and this 2? Well, they cancel. And so you just get x squared plus c, which you know is the right answer. Does that make sense?
Yeah.
Now, if you don't know, or if you're not sure what the right answer is, how would you double check if it is the right answer?
You derive it.
Right. So for homework, you know, for your questions, once you've done a question, if you're not sure, and you know, this is good exam technique as well, check by deriving your answer. So, you know, I'm saying x squared plus c is my answer. What's the derivative of x squared plus c? Oh, it's just 2x. Great, it's right. Does that make sense?
Yeah. Makes
All
sense.
right. So now I'm going to give you something, you know, without that. So let's just say x power 4 dx. Are you comfortable telling me what the answer to this is, Tiffany?
Yeah.
Not really?
No.
Okay. So just, you know, take a look. What's n equal to?
1.
Just compare.
4.
It's 4. So just put in 4. So it's x to the 4 plus 1 over 4 plus 1 plus c. I mean, there's nothing else you need to sort of twiddle around or anything, right?
Mm.
So it would just be x to the power of 5 over 5 plus c.
Oh, okay.
And since we weren't particularly sure to start with, let's quickly check the answer. So let's derive. Tiffany, if we derive that, what do we get?
You get 5 times 5 to the power of x over 5.
5 times x power 4 over 5, which is x power 4.
I'm tired. Yeah.
Yep. All right. And so basically, you know, I'll give you a few more. In fact, I'll give you this one now because I wanted to point it out. What's this?
X.
It's not x. So is this a,
X over 2? No.
is this a power of x?
Yeah. Negative
It
1.
is a power of x. So if we're saying it's a power, what power is it?
Negative 1.
All right. So if we use this rule, what do we get?
X to the power of negative 1 plus 1.
Over.
Negative 1 plus 1.
And so what do we get?
X to the power of 1.
Nope. You don't get x power of 1. Negative 1 plus 1 is?
You just get 1 plus c.
Well, you'll get x power of 0 divided by?
0.
Can you divide something by 0?
No.
No, you can't. So this doesn't work. You shouldn't be using this rule. And I'm just pointing this out now. N cannot equal negative 1. All right? So if you're trying to integrate this, you can't use this rule. Okay? In fact, do you know the answer to that already?
Isn't it just link x?
Exactly. Right? We mentioned it earlier in very, very short passing. The integral of 1 over x is log x. You know, plus c, of course, right? This is the detail I've been leaving off back when we're doing this. But yeah, the integral of 1 over x dx is log base e of x plus c. So I just wanted to point it out. We're not going to focus on that today, but I did want you to note that if you're trying to do 1 over x, this is not the rule. this rule does not apply for power of -1 because it's not in the domain, because you're dividing by n+1. Does that make sense?
Yeah.
Good. So let's just run through a few more questions, and then your homework will be to, do some more practice on this. So let's say I had something like, 5x cubed minus 7x squared dx. So note, no one cares about the 5, all right? You can just leave it. If you're integrating x cubed, remember x to the power of 3 plus 1 over 3 plus 1. You've got a minus 7, doesn't matter there. So you're integrating x squared, right? You're integrating the x squared and the x cubed. And so x squared is x power of 2 plus 1 over 2 plus 1. And what do I need to make sure I don't forget?
It's plus c.
Very good. Make sure you have it. If you don't have it in an exam, you will lose a mark, and you do need to get to that habit now so that when it does really matter, you have it. Right now, you might think it's just like we know anyway. So no, later on, you need to actually find that C is. And if you don't write a plus C, you won't be able to find what that C is. So get into that habit now. So that means you get 5x power 4 over 4 minus 7x cubed over 3 plus C. If I want to integrate something like 1 over x squared dx, how do I do that? I mean, remember the only rule you know is this, and that's the only rule I expect you to know right now. So basically, you just have to follow that through. I mean, what power of x is that?
X plus C.
No. What power of x is that?
-2.
Yeah. And then you just do the same thing, right? So it's x to the power of -1 over -1 plus c. And then, just change it to that, and you're done. All right. Let's ask a few more. So what about this?
X to the power of 3 over 2 over, wait, whoa.
Yeah, you're on the right track. Keep going.
Times.
Divided by, so it's x to the power of 3 over 2 over? Yeah. So that's not wrong, it's correct. Then it's just a question of how good your algebra skills are. But that would basically be 2x to the power of 3 over 2 over 3 plus c. And that's basically how you integrate basic things, all right? So just like how back in differentiation, your first thing was, after first principle, your first thing was to understand how to derive x to the power of n is nx to the n minus 1. We're now doing the integration version, which is the integral of x to the power of n is 1 over n plus 1, x to the n plus 1 plus c. So make sure you note this down. The integral of x to n dx is 1 over n plus 1, x to the n plus 1 plus c. Do not forget the plus c. I'll be sending you some sort of exercises to sort of work on. There are some in the book you've got, but I think the other book might be better for this one. So you just need to sort of apply that rule. Of course, same thing as differentiation. You need to know your index laws. And you need to remember this rule. Apply this rule a few times. Do the section that I will send you shortly through email. And yeah. Then yeah, you'll get lots of practice on this, which is the second branch, which we're starting now. Good.